Okay, so this here is not a journal, but you can put it in your journals. I'm going to be working out some problems from page 6 of the packet, which is about the word problems in this video. So we're going to start off with a test practice problem. So this is a problem that you might encounter on the test, and we're going to see how you would solve for it. Now, I do want to mention in the next slides, I'll be doing some problems from that page. So I'm going to be doing some word problems. So this slide here, this question here that you could have on the test is like, I give you a system of equation. We have a 2x2 here, 2 equations, 2 variables, and you have to solve it. And the thing is, I'm not going to clarify what method to use. You can decide how you want to solve it. And so I think what we need to start doing now is talking about different types of strategy and which are best. Like in this equation here, the situation, notice how like the x and y's are nicely lined up and the numbers are 2. And so the x and y's are all on the left-hand side, numbers on the right-hand side. This is in standard form is what I can see. And because it's in standard form, my my thoughts is to do it using elimination. So elimination is great when you have the system in standard form. And so that means I'm going to decide to cancel out a variable. In this case, maybe I'll cancel out the y's because I noticed they're lower coefficients. They're already opposite signs, but so are the x's. So I mean, I'm just going to choose a y because I just don't want to multiply by a very big number or get very big numbers. So if I multiply by 2 on the top, I'm going to get this y to be a -2. And so I'm going to multiply that 2 all the way through. Remember, elimination is addition. So when I multiply the 2 in, my new equation, if this is equation 1 and this is equation 2, my new equation is 18x minus 2y equals minus 12. And then my bottom equation didn't change, so I'm going to bring it down the way it is. And so when I add these two equations, wait a minute, it looks like the x's cancel, the y's cancel. So if the x's cancel, the y cancel, that means this side is just 0. But then the -12 added with +12 also cancel, so this side is also 0. And so that tells me, well, 0 does equal 0. So anytime you have two numbers or two constants that are equal to each other, then that means that this here is infinitely many solutions. So if you notice that the two numbers equal each other and are the exact same numbers, then it's infinitely many solutions. But if I were to also explain how these equations would look like on a graph, if you were to graph these two and it's infinitely many solutions, that means that the two equations, when you graph the two lines, were the exact same lines. Because they were, if they're the exact same lines, that means they will intersect everywhere, which leads to infinitely many solutions. Because solution talks about their intersection. So these are the same lines. So just be aware that most of the problems that I'll give you that are 2x2s, I won't tell you which type to use. You get to decide. And sometimes I might even ask, given the equation, what would it look like on a graph? And if you didn't graph it, you still need to know what it would possibly look like. Okay, so let's take a look at some word problems from page 6 of the packet. So here I have a problem. It's about Phil, and it says, one day Phil purchased 5 loaves of bread. So maybe that's important because it's a number, 5 loaves of bread, and 3 muffins for a total of $8. And in the next few days at the same store, he purchased 2 loaves of bread, 6 muffins for a total of $5.60. And they want to know what's the price of a single loaf of bread and then a single muffin. So right away, what I notice is that is what we're trying to look for. So I always determine, okay, well, it looks like we're looking for the price of bread and the price of muffin. And so what I'm going to do first is, because I know I'm going to be, these word problems, I'm probably going to be building a system of equation. I need to declare my variables. And variables are going to be things that you want to solve for. So it looks like I have two things that I want to solve for. It is bread, the price of bread, and the price of a muffin. So I'm going to make X the price of bread, one bread, and Y the price of muffin. So because I have two variables, if I want to solve for it, I need two equations. So this type of problem, I'm solving a 2x2 equation, 2x2 system equation. So I'm going to start by, figuring out what my two equations are going to be. And I think, Phil's shopping might expose, what our equation might be. So the first day when he was shopping, he bought 5 loaves of bread and 3 muffins. So what I'm thinking in my head is he's at the checkout counter. And so they would, scan the 5 loaves of bread, but they would multiply by how much it would cost, right? Like if the bread costs like, I don't know, $3 a piece, you would do 3 times 5. And if the muffins cost like $1 a piece, you would do like $1 times 3, and then you would add them up to get whatever your total price is. The issue is that we don't know what price is. So it's like we're doing the 5 loaves of bread are scanned and then multiplied by X, the price of bread, added with, the muffins being scanned and multiplying it by Y, the price for muffins. And when you add them up, the cashier registered or rung up $8. And so there we have it. We have our first equation. And we can do this with his second experience shopping at the grocery. So he bought 2 loaves of bread, so 2 times X plus 6 muffins, which is 6Y, equals, he spent, $5.60 this time. And so now what I'm going to do is I have 2 equations, and because it's stacked in a way where the X's and Y's and numbers line up, I'm going to be like, why not just use elimination here, right? And so I'm thinking, okay, if I want to use elimination, maybe I need to cancel out. Looks like maybe the Y's might be nice to cancel out, because 3 can be a 6 if I multiply it by -2. So I'm going to multiply the top by -2 and work this out. Remember, we want to multiply the entire equation by -2. So our equation, if we multiply by -2, we get -10x minus 6y equals -16. Our second equation didn't get multiplied by anything, so I just bring it down the way it is. And so that's just 2x plus 6y equals 5.60. And if I add these two equations, the x's cancel, giving me negative 8x equals, sorry, I did that wrong. Why am I canceling out the x's? Okay, so the y's cancel. And so negative 10x plus 2x gives me negative 8x. And then negative 16 added with positive 5.6. Feel free to grab out a calculator. But that number should be, I think, negative 10.40. And so if I divide by negative 8, on both sides, this cancels. So x is equal to, what's negative 10.4 divided by 8? Well, that's negative, that'd be positive because that's 2 negatives. So that'd be 1.3. And so looking at this here, we did get a decimal, but I just want to remind everyone that x represents the price of bread. So in this case, the price of bread looks like $1.30, right? But we're still missing the price of muffins. So we go back to okay, if I have x, how do I find y? Well, I would just simply plug this back into one of the equations here. So I might just plug it into, I don't know, the first equation. It really doesn't matter. So if I plug it into the first equation here, let me see if I can shrink this down just a bit. So if I were to plug this into the first equation, this is 5x, which is 1.3, plus 3y equals 8. So now I'm solving for y. So I'm going to multiply these two. 5 times 3 is 6.5 plus 3y, if I carry that down. Then I would subtract by 6.5 on both sides. This cancels, bringing down the 3y. And then 8 minus 6.5 is 1.5. If I divide by 3, y here is 0.5. And y represents the price of muffins, so I guess muffins cost 50 cents. And so you don't want to leave your answer as x's and y's, because first off, I just chose to use the variable x and y. I mean, someone could have chose some different letters here. And so it's really important that once you get your numbers that you go back and label what these were, what their units were, what these numbers represent. So I always, at the very end, I take my x and y. And so my x here is 1.3. Well, that tells me the bread cost. So the bread price is $1.30. And then our muffin price is 50 cents. And notice how I'm writing in money format. Okay, so there we have our first word problem. I hope that made sense. But the idea here is you're going to read through the problem, but you want to identify what you're trying to solve. So that helps you declare your variables, and you will get two variables in each of these word problems, and then you're going to build two equations to help you solve for whatever you're trying to find, your variables. Okay, so let's try to do problem 2 about Harvey. Okay, so in this problem here, it's about Harvey, and let's just read through it together. So Harvey has a $1 bill, a $5 bill, and so we don't know how many $1 bills and $5 bills he has, but in all, he has 6 bills worth $22. So that, in my mind, he has like these 6 bills. Don't know which ones are 5s, which ones are 1s, but I know when you add them together, you get $22, which is a good amount of money. And so how many of each type of bill does Harvey have? Ooh, okay. So it wants to know how many $1 bills does Harvey have and how many $5 bills. Now, some of you guys might be really skilled to the point where you could probably guess how much he has of which, because, I mean, the numbers here aren't too difficult. But if you are not good at guessing, then there is math that we can use here. So I'm going to just use x's and y's to declare my variables. But in this case, I need to know the number of $1 bills I have, the number of $5 bills I have, and then I have to build two equations. Well, the first thing I know here is that if I treat this like the last problem, so I don't know how many $1 bills I would have, but if I were to use this variable here, can I just, if I knew how many number of bills I have, I would type that and multiply by 1, right? I would take 1 and multiply by x, is what I'm saying. And that would give me how much money I have for just $1 bills. And for $5 bills, I would take the, how much a $5 bill represents, which is 5, and multiply it by the number of $5 bills I get, and that tells me how much money I have for just $5 bills. So 5 times y. And then all together, when I add it up, I should get $22 because that's how much money I have total. Or at least that's how much money Harvey has total. So I've built one equation, but I need a second one here. And so I need to start thinking, well, first off, I know that there are 6 bills here. So that means if I take the number of $1 bills and the number of $5 bills and I were to add it up, in other words, x plus y, shouldn't I get 6, right? 6 bills. So with this here, I have 2 equations now, and now I can use elimination, right? So notice how the x and y's are lined up, so I can use eliminations to help me out. And I already noticed that the x here have the same coefficients. Like that x didn't have a 1, but couldn't I just have written a 1 in front of it? And so if I look at it this way, I'm like, okay, maybe I should cancel out the x's. So I'll multiply I don't know, maybe the bottom by -1 because they're not opposite signs yet, but I'll force them to be. So the top equation doesn't change. I'm going to bring it down the way it is because I didn't have to multiply to the top equation. But the bottom equation, everything gets multiplied by -1. So -1x, -1y equals -6. If I add these two equations, I notice that the x's cancel because I deliberately set it up that way. The 5 and the 1, 5 plus -1 is 4y. And then 22 added with -6 is going to give me 16. So if I now notice that, y is the only thing here, I can divide by 4. And so y is equal to 16 divided by 4 is 4. So I have my y's. In other words, y here represents the number of $5 bills I have. So I have 4 $5 bills. Well, if there was 6 bills total, isn't that just saying, well, then for x here, wouldn't that be just 6 minus 4, my y, and then I get 2, right? So that means the number of $1 bills I have are 2. Like, it doesn't take a lot of, you don't need equations to do this, but know that you could have. So if I were to get y and I was looking for x, I would just take one of these equations. Maybe the bottom one here is easier. If I plugged in 4 in for x, well, to solve for y, I would have to subtract 4 to the other side, which leads me to the same answer as doing this process. So remember, don't leave your y's and x's the way it is. You want to label what they are. So in this case, for we have, how should I write this nicely? So the number, let's do this in blue, the number of $1 bills I have are my x value, so that's, 2. And the number of $5 bills I have is 4. And that's it, guys. I'm done. So this one's a little bit easier. At least the equations work out pretty nicely. So let's do one more story problem together. It's number 3. So in this story problem, it talks about these two people, Cody and Tori, and there's a winter sales for clothing. And so Cody bought 2 pairs of gloves, so that might be important since it's a number, 4 hats for $43, and Tori bought 2 pairs of gloves, 2 hats for $30. And it wants to know the price for the gloves and the hat. And so it's kind of like that same problem we did with the bread and the muffin. It's looking for the price of gloves and hats. So automatically I'm thinking, okay, well, then I can declare my variables as gloves, price, and then hat price. And then I would have to make 2 equations, and I can represent each equation by, the person who's shopping. So like Cody here bought 2 pairs of gloves and 4 hats. Well, that just be 2 times, the price of gloves and 4 times the price of hats, giving a total of $43. Well, that's just saying 2x plus 4y is equal to 43. Now, I could have put 43.00, but I mean, that's just redundant having more zeros behind it. So I'm just going to simplify and just write 43. Whereas for Tori bought 2 gloves and 2 hats, so that's 2x, 2y equals $30. So I'm just going to put 30 for short. And so looking at this, I'm going to try to eliminate because they're already nicely written that way. So gotta cancel out a variable. So I'm going to choose the x's since they're already the same coefficients. Maybe I'll multiply the bottom here by -1 so that they can be opposite signs. So if I multiply the bottom by -1, the top comes down the way it is because I didn't have to multiply the top. But the bottom becomes -2x minus 2y equals -30. And when I combine these two, I notice that the x's cancel, and then the y's, if you add them, 4 plus -2y is not negative, 2y. And then 43 plus negative 30 is 13. And so if I divide by 2, y here is going to be, 13 doesn't divide into 2 very nicely. It is going to be 6.5. But keep in mind, even though this y value is a decimal, that this represents the price of hats, right? So in this case, the price of hats are going to be, $6.50. It's going to be a decimal form, which is fine. Now I need to find my x value, which is the price for gloves. So I'm going to take this number and I'm going to plug it back into one of the equation. How about this time I plug it into equation 2? So I'm going to shrink this down a bit so we have some more room. So I'm going to plug this in equation 2. Remember, it doesn't matter which one you plug in, but when you're plugging it into equation 2, I'm just going to plug in what the original equation used to be. So that was 2x, I don't know what x is, 2 times y, which is 6.5, equals 30. So if I'm working this out, this is going to be 2x plus 2 times 6.3 is going to be 30. And then if I subtract by 13 on this side, that cancels. So I have 2x equals 17. If I divide by 2 to get rid of the 2, x is equal to 17 divided by 2 doesn't go in evenly, but in that case, that's fine. It's just all money at the end of the day. It's looks like it's 8.5, so $8.50. So remember, don't leave your x and y's like that. You want to label what they represent. So it looks like our x here, our glove price, is $8.50, and our hat price is $6.50. So there we have it. We have solved for this system of equation. Okay, so that's it for this journal. I hope this helps you out with the packet. Now, as for the last page in the packet, I'm going to do that on Monday, so stay tuned.